Hello everyone, welcome to this video. In this video, we'll be asking this question that how can we use normal subgroup to create new subgroup? Is there any way? The answer is yes, we can do it. And how can we do it? Suppose we have some group G. Within this group G, we have some subgroup, say H, right? Now, this is a normal subgroup. And now we can use this subgroup and take any other subgroup, say this is H1, this is H2. Now we can club this is any other subgroup, Now we can use this normal subgroup and use any subgroup to create new subgroup of this. So we can have many subgroups from it. How we can do that? Let's have a look at the result. The result here the procedure here tells you that if we take G to be some group, right, and we take H to be the normal subgroup of it, let's take K to be any subgroup of the group G. Then when we have HK, which is defined in a manner that the first element H has been taken from the normal subgroup, right, and this small k is taken from any subgroup of G, then this whole set HK would be a subgroup of G. This is the result. Now, how this is there? Let's check whether this HK is this a subgroup of G. Let's check this thing. Now, in order to check that this is a subgroup of G, what we can do, we can apply the subgroup test. Subgroup test tell you that first of all the identity should be in the set, right? Moreover, if you take any two elements from this set, then AB inverse, it should also be present in HK, right? So let's take the identity, obviously, because this is a member HK, because E is present in H and E is present in K, because K is any subgroup, this is a normal subgroup. Therefore, EE, which is nothing but E, is also present in HK. So one part is done. For the second part, we need to check the condition that for A, B, let the element A and B, they are H1, K1 and H2, K2, let they be present in HK and HK such that this H1 and H2 has been taken from the normal subgroup and this K1 and K2 has been taken from the any other subgroup, right? Such that these two elements A and the element B, they act as arbitrary members of HK. Then only our result would be true. Now we need to check that whether the element AB inverse is also present in HK. Is it the case or not? So let's have a look. What is AB inverse? Now let's substitute the value of A here. Let's substitute the value of B here and simplify the terms. So you see, if you take this much portion now, because you know H is normal subgroup of G, right? That means suppose you are taking some element K2 from G. Obviously, K2 is present in K, which is a member of G, so it is also present in G, right? So therefore, and if we are taking H2 from the normal subgroup, then this left coset would be equal to the right coset, where we have this member which could be different from this member. So let's mark this as H dash, where H dash is present in H. So let's write it here. In place of H2 K2, we are writing K2 H dash. Now when you open the inverse, this element would come in the front and this would come at the end, right? Now we can apply the same thing onto these two elements. Let's take these two elements. Because H is normal in G, therefore K1 H1 inverse, now this is present in K, this is present in H, right? Now because it is present in K, it is also present in G, because K is contained in G. So K1 is also present in G and H dash inverse is present in H, right? So that means we are taking the left coset, it would be equal to instead of this element, now we can write some other element of H. Let's call that element to be H double dash. So it is H double dash and this K1 as such, right? So this would be your member of the right coset. So let's substitute it here. In place of K1 H dash inverse, it would be H double dash K1, right? Now you can use the associative property to club up the elements. So we would have h1 h double dash and k1 k2 inverse. Now because h1 and h double dash both are member of H, so this thing, their combination would also be present in H. So this first member is present in capital H subgroup, right? And because K1 and K2 both are present in K, therefore K1 K2 inverse is also present in K. So therefore the second member is present in K. Hence this AB inverse is a member of HK. Hence by the subgroup test, we can claim that this HK is a subgroup of G. And this is the procedure to create new subgroups using the normal subgroup. So I hope you understood this concept well. Well, that is it for this video. Thank you for watching.